Token incentives can help a DePIN network solve its cold start problem by rewarding people to deploy infrastructure before demand is obvious. But those rewards must track real utility. Otherwise, the network pays for activity without building lasting value. So far, we've covered DePIN basics, categories, competition, and marketplace dynamics. Now we shift to the early stage challenge: how token incentives attract supply, stimulate participation, and help networks grow before demand is fully proven. DePIN networks often face a chicken and egg problem. Customers want dependable coverage, storage, compute, or connectivity before they commit. Operators, meanwhile, hesitate to deploy hardware when usage and revenue are uncertain. The result is a stalled network. Low supply creates weak service, and weak service keeps demand low. Token incentives can break that loop by rewarding early deployment and availability until the network reaches a minimum viable footprint where real usage can begin to take over. In the early phase, rewards reduce operator risk and bring more hardware online. More supply can improve coverage, lower latency, and increase reliability. Better service then makes the network more useful, which helps attract real customers. The key test is what happens after that. Token emissions cannot carry the system forever. A healthy flywheel gradually shifts value creation toward usage revenue, so demand, not subsidies, keeps operators engaged. The purpose of early incentives is not simply to make the network look bigger. It is to create credible availability, enough coverage, redundancy, and uptime that users can safely rely on the service. That bridge matters for wireless, compute, storage, sensors, and other DePIN categories. The trade-off is overbuilding where demand never arrives. Useful supply is category-specific. A network should not reward infrastructure just because it exists. It should reward capacity that customers can actually use. For wireless, that may mean coverage where people are with strong signal. For compute, it means the right hardware, available at low latency with proven performance. For storage, durability, and fast retrieval matter. For sensors and mapping, freshness, accuracy, and location can be the difference between valuable data and noise. Reward design starts with a simple question: what behavior should the network make more attractive? Coverage rewards push nodes into places where presence matters. Availability rewards make reliability valuable, so participants stay online and responsive. Capacity rewards encourage useful resources like storage, bandwidth, compute, or energy. Usage-based rewards tie payment to verified customer demand. Strong DePIN systems usually combine these primitives because early networks may need supply growth, while mature networks need quality, utilization, and dependable service. Location-based rewards shape where infrastructure appears, not just how much gets deployed. Higher incentives can pull operators into underserved areas or zones with strong demand. Lower or zero rewards can discourage saturated or restricted locations. The risk is overpaying for clusters that look valuable but add little real coverage. That is why these systems need demand weighting, uniqueness checks, and strong geospatial verification to prevent spoofing and low-quality placement. Beyond location, DePIN rewards should measure usefulness, not just installation. A node that is online 99.9% of the time is far more valuable than one that disappears during demand spikes. Quality metrics add another filter: latency, signal strength, throughput, benchmark results, or data accuracy. Capacity rewards then recognize operators who contribute more resources, not just minimum hardware. The goal is straightforward: pay for reliable service delivered to users, and avoid treating low-quality infrastructure as production-ready. As DePIN networks mature, the strongest incentive model moves beyond paying for capacity that might be useful. Rewards should follow completed work that customers actually value: data transferred, compute jobs finished, storage retrieved, energy dispatched, or connectivity delivered. The key is verification. A node's claim needs proof, such as telemetry, receipts, cryptographic evidence, or third-party validation. When rewards are tied to verified usage, emissions become less speculative and participants optimize for real demand. Verification is what keeps incentives credible. A device may claim it exists, is in a location, stayed online, and delivered useful work. Each claim needs evidence: cryptographic proofs, attestations, telemetry, audits, or independent validators. The hard part is adversarial design. Participants may spoof location, create fake identities, generate fake traffic, or collude. Strong verification improves trust, but adds cost and friction, so networks must balance accuracy with decentralization and usability. Reward design determines what participants actually optimize for. If emissions pay for proxies like coverage, uptime, or traffic, rational actors may chase those signals even when no customer demand exists. That can lead to devices in low-value areas, spoofed locations, fake usage, or idle hardware kept online only to earn tokens. The network may look larger on paper, but create little real utility and add sell pressure. Token rewards are useful when they bootstrap real capacity. The risk appears when infrastructure grows faster than paying demand. Emissions keep flowing, but usage revenue is not there yet. Operators still have bills, hardware, electricity, hosting, and maintenance. So they sell rewards to stay solvent. That selling can weaken token price, which makes incentives less effective. A healthier network gradually shifts from subsidized growth toward revenue backed by actual utilization. Bootstrapping works best as a sequence, not a permanent subsidy. First, incentives create credible supply in the right places, measured by deployments and coverage density. Next, rewards shift toward reliability, uptime, quality, and performance. Once the network is usable, incentives follow verified demand, such as utilization and revenue per node. Finally, the model reduces emissions dependence through pricing, revenue sharing, and tokenomics that make real revenue carry the system. The core lesson is this: tokens can jumpstart DePIN supply, but only useful verified work should earn durable rewards. Strong designs discourage farming and low-quality deployment, then shift from subsidies to real demand, sustainable unit economics, and stakeholder value. Next, we connect incentives to tokenomics, ROI, and governance.